10 minutes, perfect. Thank you so much for accommodating this very last minute change in plans. I'm sorry I can't be there in person today. So I'm going to share with you some preliminary insights from an early stage research project that very much speaks to this theme of urban inclusion. And specifically, I'm interested in residential patterns within developing country cities. We all tend to think that cities in developing countries provide an important gateway of economic opportunity for households. But a limiting factor that affects the extent to which poor households are actually able to access economic opportunities in cities has to do with where within cities they end up and physical distance to jobs, public goods, and so on. And so when we think about the way in which developing country cities are configured in terms of their internal composition, we can think of two archetypes. There are instances where you see the high rise next to the slum, like in Rio de Janeiro, in this picture you can see on the left. And that is suggestive of a city where the poor end up living in pretty close contact with rich neighborhoods and economic opportunity. But at the other end of the spectrum, you also have this other archetype of a city where poor households are kind of piling up at the periphery. Like in this picture, for example, you see an example from Mexico City and Sao Paulo. And then it's pretty different in terms of access. Poor households are very far away in terms of physical distance from the economic opportunities that presumably are located where the central business district is or where richer neighborhoods are. So the idea with this project is to try and understand to what extent cities look like one or the other and whether it matters for economic outcomes. So the first step in this project is to kind of examine at a descriptive level these patterns. And I'm using Brazil as a setting for a variety of reasons. In general, it's pretty challenging to examine residential patterns within developing country cities because of a lack of granular data at the within city level. So Brazil is interesting because it has very rich data from the census. So what I'm showing you today uses the 2010 census data. When I'm referring to a city, it's actually a municipality. And when I'm referring to a neighborhood is a setor censitario, which is like a enumeration area with on average about 400 households. And there's very rich data at the setor level, which I'm exploiting. So here, just to show you visually what kind of patterns I want to try and capture, I'm showing you Rio versus Sao Paulo. And as a proxy for what I'm calling rich versus poor neighborhoods, I'm plotting the share of households that have income below the minimum wage. And you can see two patterns that are visually quite different. Sao Paulo looks kind of like a monocentric city where all the rich are in the center, all the poor are in the periphery. Rio looks a lot more mixed with kind of poor neighborhoods interspersed with rich neighborhoods. And so with this project, the idea is to begin by quantifying these patterns and then eventually ask ourselves whether they matter for various outcomes. What I'm showing you today is just purely descriptive, and I'll highlight some of what the next steps are for this project. So how do we measure these different patterns? If we turn to the literature, Okay, if we turn to the literature, there's of course a vast literature on residential segregation in the US, focusing on Black-white residential segregation. There's a lot less on developing countries. The only paper I'm aware of is Adukia et al. On residential patterns within Indian cities. But what the literature has, what these different papers have in common is that they all employ standard measures of segregation that are not spatial. So they don't really capture this aspect that I have in mind of essentially physical distance between rich and poor households or between poor households and employment centers. The benchmark index used in the literature is the dissimilarity index, but a known paradox with the dissimilarity index is that a city that looks like a checkerboard, like A, and a city that looks like spatially segregated, like B, can have the exact same dissimilarity index as long as the internal composition of the neighborhoods is the same. But plausibly, it is important to bring in physical distance because it matters for access, because a lot of public goods in cities are delivered along spatial networks, and then because a lot of city level externalities, whether they are positive externalities like agglomeration or negative externalities, have a decay pattern in space. And from a policy perspective, it's useful to think about inequality in accessibility as cities expand. So with this in mind, I come up with two novel sets of indices that measure this notion of distance segregation. So the simplest version is essentially looking at the average distance between poor and rich neighborhoods, and then you can apply different kinds of weights. This is, of course, correlated with just how large the city is overall, but we can easily control for it. The second type of indicators have to do with what I'm labeling as exposure, and they kind of have the flavor of market access, meaning that when I measure rich exposure, I mean looking at essentially the number or the share of rich households around you weighted by inverse distance, again, similar to market access. So these are the two sets of indicators, again, to give you a visual sense of how they map to actual cities. These are two examples of cities that, to me, are kind of one more close to the segregated pattern, one more closer to the integrated mixing pattern. The average poor household in Curitiba is exposed to about 1,400 rich households per square kilometers, whereas the average poor household in Rio is exposed to 5,000 rich households per square kilometer. So again, this captures access of the poor to rich neighborhoods, which for me is kind of the proxy for economic opportunity, and we can easily adapt it to include employment or other things we care about. Now, turning to distance, here I want to show you kind of the distribution for my distance segregation index. So this is the simplest version of the index, meaning that it captures the average distance between poor and rich neighborhoods, and I'm normalizing it by the average distance between any two neighborhoods in the city. So this indicator is centered on 1, and it will be exactly 1 it will converge to 1 in a random city where I essentially randomly allocate poor and rich people. If we think of a city where the poor and rich are allocated randomly in space, this indicator will be equal to 1. So here I'm plotting the distribution essentially for this index for the top 600 municipalities in Brazil, where whenever you see mass above 1, that implies these are cities that are more distance segregated. Where you see mass below 1, it means cities are distance integrated, meaning the poor and the rich are closer than they would be in a random city. And with different colors, I'm showing you this exercise, this distribution for different definitions of poor and rich. So I can look at literally the poor versus the rich with different definitions of who is poor and who is rich. But then I can also look at other dimensions like racial distance segregation, white versus non-white households. And then interestingly, I can look at slums versus non-slums. That's something very unique about the Brazilian census, that the census provides you with an indicator for whether a neighborhood is a slum, is an aglomerado subnormal, based on a bunch of indicators that have to do with physical characteristics, but also titles. So the brown line represents the distribution of the distance segregation for slums versus non-slums. And I think it's interesting to contrast this distribution with the distribution for the income segregation. So what this tells me is that essentially, if you look at where slums are, they tend to be more distance integrated within cities than poor neighborhoods that are not slums. And to me, this is of course purely descriptive, but I think this is consistent with an argument you hear about slums that says that essentially slums are the way in which poor households are able to access good locations in the city. If you're a poor household, you want to locate near economic opportunity, you're likely going to be priced out of the good access areas if you look at the formal market. But perhaps you can find some pockets of land where you can squat. And this story is kind of consistent with this finding that the slums tend to be better integrated in terms of access in the city than poor neighborhoods that are not slums. Also, interestingly, this distance segregation index is not really correlated with the standard dissimilarity index, which reinforces the idea that it captures something different. But it is positively correlated with the Gini index, meaning that essentially cities that are more unequal in terms of income distribution are also cities where the poor and the rich are physically further apart, which is a pattern that I'd be interested in exploring further. So what is next for this project is to be able to bring in some outcomes and say something causal. So for that, there's an identification challenge associated with this question, that cities evolve into the Rio versus the Sao Paulo pattern for very different reasons. And a side project will examine the role of colonial urban planning and the disease environment in explaining why cities ended up configured in one way or the other. But for the purposes of this project, what I'm going to do next is exploit geography and the fact that poor households tend to settle on land of worse quality as measured, for example, by slope. So this is kind of the 0th stage where I can show you that this is a regression at the sector level, at the neighborhood level. Essentially, whether you're, how poor your neighborhood is and whether you're a poor neighborhood is predicted by slope. And then the idea is to build on this to create essentially a predicted version of the distance indexes, where instead of using actual poor neighborhoods, I'll be using predicted poor neighborhoods. So the idea will be to kind of exploit the fact that cities vary in their relative placement of high slope areas. And so with this in hand, I plan to examine outcomes such as public goods provision, contrasting spatially delivered public goods with public goods that are not spatially delivered, and then political economy outcomes such as voting and potentially crime. So that's all I have. I'm happy to take questions.
Okay, so thank you very much, Nina. We now have time for 2 or 3 questions from the audience. And importantly, just make sure that you get the mic when you ask your questions.
Just a quick technical question.
Oh,
Michael, maybe just introduce yourself, because Nina can't see you.
Yeah.
Oh.
Yeah.
Okay, yes.
It's Mike here. So I didn't quite follow how you could be more integrated than randomly allocated. So just wondering if you could explain that.
Because there's clustering. So in a random city, right? What I do is I can literally do this exercise simulating for actual cities. I take the actual counts of poor and rich people and I allocate them randomly, and you will get a city that looks like a pure checkerboard, essentially. Now, in real world cities, there is clustering of neighborhoods of similar income. So that pattern alone can give you cities that are more spatially integrated than the purely random checkerboard.
Thanks.
And so do we have any other questions? And maybe if we have 2 more, we can take them both at the same time. Remy first.
I don't know if you can hear me. Yeah, I think an interesting question would be the interclass marriage, which is a factor of mobility. You get married with like people who are, wealthier than you, poorer than you. So I guess if you had attention to that, it would be nice to look at that.
So I think like what I'm really ultimately interested in is upward mobility. The challenge is that is data, really. Like I'd love to look at, in general, intergenerational mobility for households that live in neighborhoods that are more integrated or less integrated. That is a difficult exercise to do given the data constraints in a developing country setting. But I agree, people outcomes and mobility, upward mobility would be something I'm very interested in, and the kinds of outcomes you described too is just a data limitation, I think.
This is Luis Quintero. I'm asking about your, market access type calculation. Are you looking at times or distances? Because especially in Latin America, cities are notorious for having low income and high income places that are spatially located near each other, are not accessible.
Yes, right now, that's a great point. Right now, I'm just using physical, like Euclidean distance. I agree, you can have a slum and then the high rises, but then in the middle, there's something that makes it actually very hard to cross that line. So ideally, if I could enrich the measurement of distance to account for infrastructure, or maybe at a more basic level, just maybe slope or something along those lines, I agree that would paint a richer picture.
Great. So thank you very much, Nina. That was
Thank you.
Sorry you couldn't be here. But yeah, thank you very much.
Thank you.
Great. And so we'll now have Jingwen Zheng, who is a PhD student at GW. present her work on estimating the negative externalities from urban blight. And let's hope that our works. Stuff. Okay. All right, Jingwen, go ahead. Use the mic.
So hi, I'm Jingwen. So today I'm going to present my work with Remy on slum clearance and economic development. So let's get started. So there are slums in the world, but we know very little about the local and aggregate effects of slum clearance. So our work is to use a natural experiment in Hong Kong, the demolition of Kowloon was city in Hong Kong during 1987 to 1994, to understand the local and aggregate effects of slum clearance. So this is the Kowloon was city, around 500 buildings of 10 to 14 stories and a population of 35 to 55,000 inhabitants. Okay. So that will make sure everyone saw the Kowloon was city. Okay. All right. So this was how it looked like from the outside. And it was how it looked like from the inside. So we call it City of Darkness because of the verticality and lack of light, and as well as social ills inside the slum. So basically, as you can see, it was a vertical mega slum, no man's land. It was in the British Hong Kong territory, but was under Chinese sovereignty, and received the refugees from mainland China. No taxes, no police, no public services provided inside. And also the poverty rate is very high. Informal activities inside, including many small factories. It was city of darkness because of the high crime rates, drugs, gambling, quackery, sex trade. And it was the most populated place on earth. As you can see from the red figure, it was around like 3 times of the population density in Dharavi in Mumbai, and also 10 times of the population density in Kibra in Nairobi. So it was where it was located in the center of Hong Kong, 0% of the area, but 2% of total population of urban Hong Kong. So we're looking at a natural experiment of moving these 2% of population of urban Hong Kong. So the slum clearance policy was a surprise for the world and also for local people. The colonial Hong Kong government announced its decision to tear down this slum in 1987. At the time, it was exogenous because of the 2-year secret talks between the two governments. The demolition happened very quickly from 1987 to 1994. So a new park was built on the original site, and it was how it looked like today, like 10 minutes tour to this urban park. So there are positive effects such as removing an eyesore, redevelopment of the place, transfer of slum-based economic activities to neighboring areas, and a reduction in crime. But also, like a negative effect such as loss of consumers and employees for nearby businesses, rising housing prices due to reduced housing supply in area, and also potentially crime displacement to neighboring areas, thus increasing crime. So our work uses panel data over 40 years to study the local effects of demolition KWC. We have location level data, both at the neighborhood level and blocks level. We have the years from 1981 to 2016, so every 5 years of the data. And we look at the outcomes as listed here. So for the time being, our current analysis focuses on the 59 Kowloon neighborhoods as marked in dark blue in the map. So basically for the 59 Kowloon neighborhoods and for the 8 years, we use this specification where close KWC represent the distance of the neighborhood to KWC, measured by negative log Euclidean distance to KWC. So when we move to the block level data, we're going to use distance fees later. We capture spillover effects only to compute the outcomes. We always exclude KWC's numbers in the neighborhood containing KWC. And we include neighborhood fixed effects, year fixed effects, and also use only standard areas. And we control for the redevelopment of the old Capita Airport and also proximity to Kowloon's economic center. So our preliminary result at a neighborhood level in Kowloon. As you can see, for the total population, after the slum demolition, we saw a rise of the total population, potentially because of the influx of the KWC residents, and then we saw relative population decline afterwards. So why is that? And as a next step, we look at the per capita income. So the per capita income decreased after the slum demolition, maybe because of the influx of lower than average income former KWC residents. But then over time, we saw gentrification increase in the per capita income. And we try to verify the gentrification by looking at other outcome variables as well, such as the population share with only primary school or below education. And we saw over time the decrease of the share of this group of population. And we also look at the other population speaking other Chinese dialects. We saw the population share decreased over time as well. And then, but for working age population, we saw that after 2000, we saw a rise in the working population. And then for population with skilled occupation, we saw the rise over time as well, like after 2000. So all of these, outcomes showing that over a long time, we saw a gentrification in the neighboring areas. And then we started to look at different industry sectors. So first of all, we look at the market services. Like it was declining in neighboring areas over time. But then when we look at the industry sector containing the construction and also manufacturing, it was increasing during and post the clearance and kept the plateau afterwards. So we suspect that the KWC informal industries initially moving to the neighboring areas. And then as for the non-market services, we saw it was rising over time after 2000. So as for the initial figure about the market services reduction, was suspect that it was firstly replaced by the increase in informal industries from KWC and later replaced by non-market services over time. So the gentrification, like we suspect from the informal industries giving way to the non-market services. Okay, as for the next steps, we will use block level sample, including 12,000 plus observations. And we will use more flexible treatment, controls for rehousing by government. And this is the street block map that we are going to use for our next steps. And those are the street blocks surrounding KWC. And we are going to examine changes in the nearby socioeconomic characteristics. What is really amazing is that we have over 40 years data in income, so that we can literally track the changes over time in income dimension. And we also have compiled panel data on housing prices, land prices, and crime. And our final goal is to use the quantitative spatial model to rationalize the estimated local effects and study aggregate effects. So that's all. I'm happy to take questions.
Just need to confirm that there are no questions online, at least yet. So anyone online, please ask if you have a question. We'll take questions from the in-person audience first.
Great. Good morning still. Could you speak on, did any of your research talk about the people once the buildings were demolished, where were they displaced to? Do you have any research? Where are they now? Which they migrate to?
Just some institutional questions. So the first is just about this vertical slum. So how did it come to be developed and vertical? You usually think of slums as being, low height. and also what replaced the walled city as we're thinking about the evolution still over.
You answer that before I give the question, or?
Yeah, you can give the question now.
Okay. How are you analyzing the data itself to make sure it's actually fact versus fake news or biased news?
Okay. So thanks for the questions. First question about the displaced persons from the slums. They were literally displaced to public housing, and we have the archived documents reporting where they are moved to. So in our later analysis, we are able to control for those 3 blocks that they move into afterwards. And then as for how it was developed as a vertical slum, it mainly happened during, so at the very beginning, the slum was, literally low-rise houses. But then around 1960s to 1970s in Hong Kong, like the housing prices rise very quickly. And then the kind of like the slum residents inside this urban slum, they try to capture the opportunity to, because, like, as I mentioned before, there were no police, no regulations like put inside of the slum. So those people, like, they try to seize the opportunity to build taller buildings, which, like, doesn't meet the building standards of Hong Kong, of course. And then for that reason, so that they can try to rent the tall, the houses to those low income people, or those people who are actually working outside the KWC, but they try to seek lower rent from the houses inside the KWC. So it was like how it was developed. Yeah. And in terms of what, so for the KWC, after it was demolished, it was replaced by a park. Literally very small little park afterwards. No housing supply or residential building set, the original set. As for the data, we use the census data to support our work, and including the maps matched with those data from 1981 to until 2016. So.
And sorry, and we do have one question online. So let me just repeat it. Indra Klein is asking, to what degree has or did technology impact the resulting changes in Kowloon Walled City? And maybe I'd add to that because I have a little insider information, but I also heard that there is a transport investment nearby. So I don't know, how does that relate to, or how do you interpret your changes with respect to that?
So I know that, so basically, as you can see in our regression, we try to control for, I guess you mentioned about the Capita Income closure. And also the transport. So because of we actually try to control for that by including a dummy variable in our regression, and also all those neighborhoods that are under the flat plans, so that we control for that in our regression. So I did control for that. And so I think that's a key thing. And also
and I guess basically technology more broadly, how you think it might impact. Or maybe these transport technologies, let's think about might impact broad. Clarification. All right. So, with regard to the makeup of minorities, would you provide insight into the challenges with respect to cultural nuances or any areas?
Okay. So, as I mentioned before, so this urban slum received many refugees from mainland China who mainly spoke the local dialects at the very beginning. But then afterwards, we suspect those people, some of the major composition of this urban slum residents, they moved to the neighboring areas, but later on, you saw the gentrification of the neighborhoods, so they press out of the neighborhoods. But I think basically, people live there, they try to merge into the culture. So that's how they moved, after the slum. Yeah. Okay, thank you.
All right, so my short tenure as chair is finished. I'm going to pass the floor over to Carlos Castellan.